Hey, what's up, guys? Thank you very much for being on Electreca. Now, how do you control power fluctuation? So here in what we do here, the equipment here are very much affected by power fluctuation. They can't curb power fluctuation. So in that case, if you don't do anything, sometimes these sites can really go down just because of that fluctuation. So this is what we are doing. An introduction of a contactor, an introduction of a phase failure and a timer can help you to curb that fluctuation. So this is what happened. Okay, so we have three things here. Now you have a contactor, you have a timer, and phase failure. Now what happened, you have a phase failure which will monitor power. Then you have a phase failure which will monitor power. And then what happened, if maybe power goes down below the threshold, now this guy will disconnect the circuit, okay? Now, we have to add him this timer here, and what the timer does is a delay. So this is an on-delay timer. If this guy allows power to flow through the circuit, then this one will delay the contactor to engage. And why the delay? The delay is there because, let's say, maybe there was a fluctuation. Power went down maybe to 180, and that's the threshold. And after a few minutes, that power restored. So if you don't have a timer, that means that this guy, if he senses the power is okay, he closes. If he senses the power is not okay, then he disconnects. But if you have a timer, you delay, okay? You can delay 2 minutes, 5 minutes, 30 minutes, an hour. It depends on the healthiness of that voltage, okay? All right. Now, the contactor is just a switch, okay? The contactor is just a switch. Now, what happened? The power from the timer will enter this guy. It's the one who will be actuating the coil for this contactor. And also, this one, when you rate it, you have to bear in mind how much load, how much current will pass through the thing, okay? So, for instance, if the system rating probably is around 40 amp, so you must make sure you have this guy either equivalent to 40 amp or maybe 20% more than that, okay? You cannot put this if it's below the system rating, okay? Now, for instance, we have a breaker here. This breaker is for 100 amps, okay? And it is able to protect our circuit. So, follow along as we do this wiring. And I'll put a schematic, okay? This is a very simple thing, and you can do it in your home if you have intermittent or power fluctuation, okay? The one more thing also you have cautious about is, you know, in your household, especially in domestic setting, most of your gadgets will really not directly affected by under voltage, as in the effect will not be visible by your eyes, but most of gadgets, they will wear out in time. For instance, most of our gadgets are rated at 220 or 240 volts. Now, but they can allow to as low as, probably if it's really bad, around 180 volts, okay? But if that voltage goes further lower to, let's say, 100, you know, if it is a power break for a computer, those electronic things, they get damaged, Okay, if it's a TV set, okay, it can get damaged. Okay, so you must, unless you're sure that your gadgets have a range of voltage, probably from 100 maybe to 140. Okay, so it can work comfortably with low voltage and high voltage. Okay, high voltage, I mean as high as maybe 275, and low voltage maybe up to 100. Okay, but if not that, then you need this kind of small system to help you to curb that under voltage of power fluctuation. Okay. All right, now we've already oriented our circuit here. So we have here, you're seeing two contactors, two timers, you're seeing two phase comparators, you have some breaker here, and then the main power breaker here, okay? So from the cutout, the main purpose of what we're doing here is to curb power fluctuation. Now, in the sites like this, they are very much vulnerable to power fluctuation. Now, that's why we have to, to introduce something like this. Now, let me tell you something about power fluctuation. What happens is you might see power keep on, coming on, off, or voltage will be going below the threshold all the time, okay? So that means that your system will be going on, off. That's not good for this kind of system. They will definitely, a site will shut, okay? Now, I have two contactors here. I have two timers, two phase comparators. Now, why do I have two? Because I have three phases in this system, but I have two because of I wanted to reduce on the cost of this, so definitely I will use two. I can't use one because it's not possible to put here all the three phases, all the two phases. Why? Because our system can still use single phase if it's the most healthy one, okay? Now, if I feed all the three phases here, or all the two phases here, if one phase fluctuates, then it means that the entire system will go off. So that's why I have to put two separate circuits for two phases, okay? So the red phase has a circuit, the yellow phase has a circuit. So if all phases are healthy, definitely they will be sending power to the equipment. If one phase is unhealthy, then that will be stopped, and then the healthy one will still go to the equipment, okay? All right, now we have two contactors, two timers, and the two phase comparators. If you don't know how the phase comparator works, I have a video, I'll put a link in the description, and the info card. If you don't know how a timer works, I'll put the video, I'll link all those videos. Also, if you don't know how a contactor works, all those videos are on the channel, I'll link them in the description. Okay, so let us try to do the wiring here, okay? Okay, now here, because we have two, sorry about that. So because we have two, so we need to first to wire the power circuit first, okay? Power circuit. Now, we have here the cutouts from the incoming cable to our cutouts. Now, from our cutouts, we'll feed to these contactors. Now, this will be the incoming. Now, the other side, we feed wire, will come to outgoing breaker, and then down to the load, okay? So these are cutouts. I want this one to enter here. And then you must make sure that your connections are tight, okay? You really must make sure that you're tight, because you lose connection, it's not good. The cutout will be burnt, cables will be burnt, okay? And also the contactor contacts, okay? So that is tight. Let's see this one. Okay. Yeah, that's quite sounding. Okay. Now let's get another phase. Okay. Ah, yeah, that is quite tight, eh? Okay, now let's say another one. Remember, we said each contactor carries a phase, eh? Each contactor carries a phase. So this is a blue phase. So this is a blue phase, which is running through the contactor to the outgoing MCB. Let's get the ready one, eh? Oh, yeah. Okay. You just have to make sure that your connections are quite tight, okay? Okay. Now that's the connection. So we are done with the power circuit, okay? And if you look at here, you will tell each phase running through a contactor, then to the outgoing MCB. The red phase, the blue phase, the same. Now let us go to the control circuit. So this circuit, I'll try to link up to the website, probably, if you need it, okay? All right, a small roll of auto cable, which we're going to use to do the wiring, okay? Now, for the auto circuit, this is what we are going to do for the control circuit. Now we have two breakers here, each breaker for each control circuit. So let us start with the one, okay? Okay, first we'll take power right here because we are wiring for a blue phase, okay? You can pass it up. Then we connect it here. Okay, now when you're dealing with phase comparators, especially these GIC, they can do 3-phase and they can do single phase. So if you need to use it for single phase, then you will have to short any line or line 1 with a P, okay? So now we are connecting that to L1. We short P and L1, okay? Now we need to get power for this guy here, right here. All right, now we need to get to supply our timer, and from the timer now to the contactor. Now we are beginning with, I think, let us begin with the ready contactor, okay? Okay, so another thing, GIC has 3 contacts down here, the control contact. So number 15 is common, 15 is close to 16 and open to 18. So we want this number 15 to give it power, then we take number 18, okay? Then we need number 18. Now from number 18, we'll be going to this timer here. And that timer has got 3 contacts also. Of course, you have to feed it A1 and A2. We'll come back to that. Okay, so number 18 will do what? Number 18 will be feeding A1 together with number 15 of the timer. Now, from number 18 to A1 of the timer of the red contactor. And then we are looping from that A1 to number 15 of the same timer. Now, what we need, because number 15 is linked to 18 in open position, normally open, and then with the 16, normally closed. So now we need number 18 now of the timer for the ready contactor. Okay. Okay, now this one will be now going to A1 of the ready contactor. Okay, we are almost there. Now, one contactor is done. So we want to lubricate the same on the second contactor, then we do the neutrals, okay? Yeah, now that we already finished our second connection, now we have a system in place which is able now to protect our equipment. Now you realize that we, out of the three-phase system, we have only connected two phases. So we are controlling two phases. So this means that if one phase fluctuate, then the system will take the other available phase. Okay, the other thing also is that these most of the telco equipments are very sensitive and vulnerable to power fluctuation. Now imagine during power fluctuation, the system will be distorted. It won't even be able to call a generator. But at least if you put a system like this in place, it will be able to disconnect the faulty phase, or if not both of them, and now the generator can come online. So I hope you've learned something out of this tutorial. Please, if you like, and if you've watched up to this moment, don't forget to subscribe, to like, and to share. Thank you very much for watching. Until next time, I'm out.